Good day, grade 12 learners. Welcome to today's physical sciences lesson. My name is Tandwi Uwane. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center. Today we are going to put our focus on paper 2, which is our chemistry. As you have seen that yesterday, we're based in paper 1. So our most focus today will be paper 2, that will be written on the 26th of September, that is next week, Tuesday. Now, yesterday we talked about the documents that you will need in order for you to be able to prepare for your prelim examination. So I'm not going to go through these documents again, you already know them, but what I'm saying is that make sure that all these documents are there for you to be able to prepare for your prelim exam. The structure of the paper looks like this. Our chemistry paper, just like paper 1, is having 10 multiple choice questions, whereby each question is 2 marks, and the total of all the questions is 20 marks. We also have our section B, which is our structured or long questions, which the total of the 2 is 130 marks. So the total, the entire paper will be out of 150 marks, which is the duration of what? Of 3 hours. And you know, when we say it's the duration of 3 hours, we also mean that you must make sure that you use your 3 hours very effectively. Now let's look at the weightings of the paper. You must expect to have chemical change and matter and material. Chemical change is 92 marks, and matter and material is 58 marks. Adding them together, you will get 150 marks for the entire 3 hours. And we also rated the paper according to different levels of difficulty, which is called cognitive levels. So you can see that all the percentage are given to you in order for you to know how much you prepare for your examination. Now this is the structure of paper 2. Our question 1 is multiple choice questions, and all topics are examinable. Question number 2 will be our organic molecules, but the main focus will be naming, which is IUPAC naming, and also the homologous series. Question number 3 will be based on physical properties of organic molecules. Question number 4 will still be organic molecules, which is organic reactions. So you can see that question number 2 up to question number 4, they are all organic molecules question. And this is our matter and material. And we said matter and material is out of how many marks? Is out of 58 marks, plus or minus 58 marks. Meaning that it is even more than the level 2 of the entire paper, because it's more than 33, it's more than 30%. Question number 5 will be the rate of reactions. Question number 6, chemical equilibrium. Question number 7, acids and bases. Question number 8, galvanic cells. And question number 9, electrolytic cell. The reason why I'm trying to give you the structure of the paper is for you to know if you want to start with a specific kind of a question, you definitely know where you are going to find that question, and you can also during your reading period go to that question and try to gather as many facts as possible. So this is going to be the structure of the entire paper, which is our paper 2. Remember, the prelim examination is the resemble of our final exam. So if you understand the prelim examination, you definitely understand the final examination. Now here are the topics that are covered in paper 2. As I said, we have homologous series and IUPAC naming, physical properties and reactions, which falls under organic molecules. We have our rate of reactions and our chemical equilibrium. We also have the 2 electrochemical cells, which is a galvanic cell and the electrolytic cells. Yesterday we talked about the importance of multiple choice. So I'm not going to too much in terms of how do you need to answer multiple choice and how important is our multiple choice. So you need to make sure that before you make a choice, you are definitely sure that your choice is the correct one by minimizing the number of distractors. And then the next thing that I will emphasize is that do not skip any question under multiple choice. You rather write something rather than just leaving the question blank, because sometimes you will never know, maybe whatever that you are going to choose that time definitely is going to be the correct answer. Now, let's look at our homologous series. Our homologous series, which is our organic chemistry, is going to be a homologous series, functional groups, general formulae, structural formulae, condensed structural formulae, and molecular formulae. So it means we need to remind ourselves what is the difference between all these formulae, because they will be required, or will be required, it will be required from us to maybe sometimes draw a structural formula or a condensed structural formula or a general formula. We also need to remember the saturated and the unsaturated. This one will be only based on the hydrocarbons. So it's only going to be the definitions of saturated and unsaturated hydrocarbons. And by now, I think we know what are hydrocarbons, those compounds that are composed of what? Carbon and hydrogen. We also need to remind ourselves about the isomers, where we talked about the structural isomers, which are the compounds with the same molecular formula but different structural formula. And our isomers will be based on the functional isomers, positional isomers, and chain isomers. So it is very important that you also go back and see what is the difference between different types of isomers. And remember, the isomers, all of them, they will have the same molecular formula. The only thing that will be different is their structure. So you need to say what makes their structure to be different. Is it about the functional group? Is it about the chain length? Or is it about the position of the functional group? We also talked about the names of the functional group in some of the instances where names were provided. And we looked at alcohols where they were provided carboxyl group, carboxylic acid, they were hydroxyl group for alcohols, carboxyl group for carboxylic acid, carbonyl for the ketones, and phenyl for the aldehyde. So those are all the terms that you need to remember as you are going through and preparing for your examination. Now, the functional group table is there in your exam guideline. I just felt that we need to also remind you that the functional group is very important. You need to go back and check your functional group. Now, when you look at the structure of the functional group, which is what I wanted to just talk about, you can see that normally the hydrogens are not included when you have to draw the structure of the functional group. But there are those cases whereby you will find a hydrogen being part of the functional group, and it's only for alcohols, aldehydes, and carboxylic acids where you will find a hydrogen as being part of the structure of the functional group. However, all the other organic compounds or all the other homologous series, hydrogen is not included. And make sure that there are always 4 bonds around each carbon, whether you are doing a structure or whether you are doing a structure of a functional group. And specific names, as I discussed on my previous slide, are being given for some of the homologous series functional groups. Now, as you know that this is about naming, this is about recalling the definitions, this is about explaining the issues of functional groups and their homologous series, then we need to also remember how do we do our IUPAC naming. I always say you cannot name any substance without being able to identify it. So sometimes you can use a functional group to identify a structure. Sometimes you can use a suffix to identify a structure, like ANE for alkanes, ENE, oic acid for carboxylic acid. So those are the things that we can use, or those are the characteristics that we can use for us to be able to identify where does that specific compound belong to. Then the next thing you need to identify your longest chain. Remember, for the longest chain, you will always get a mark, because identifying a longest chain is a skill. So when you identify the longest chain, you are not numbering the carbon, but you are just saying how many carbons in the longest chain are successively connected to each other. Then that's when you can do the numbering of carbon. Remember, the numbering will depend on many things. It can depend on where is the functional group, in cases where the compound is having a functional group. It can also depend on where is the substituent in terms of a compound where there is a substituent. Or it can also depend on the number of substituents, maybe the most substituted carbon or the most substituted side. So all those, you need to understand how do you see that you are numbering in terms of the functional group, how do you see in terms of the most substituted carbon, and how do you see in terms of the most substituted side. So, and also the alphabetical preference. So all those 5 facts that I just mentioned, you definitely need to go back to all the structures that you already done with your teachers and check whether you can classify in which way are you numbering your carbons. Also remember, we always put hyphens between the number and the alphabet. We put a comma between 2 numbers or 3 numbers. There are no spaces when there are 2 alphabets following each other, and all the rules, as I'm saying, they are provided to you on your exam guideline. So that is why we said it's one of the documents that you must have as you are preparing for your exam. Now let's look at different multiple choice questions under question number 2. Let's look at this question. It says, which one of the following is the general formula of alkanes? Remember, immediately when a question is asked or is posed to you, you need to always recall the facts about what you know about that term, like the word general formula. Already you know that we have alkanes which have CnH2n plus 2. We have alkenes which have CnH2n, and the alkynes which is having CnH2n minus 2. So immediately when you recall what is required out of you, you can just go straight to the options. You can see that this one is not a hydrocarbon, so it's off. The only it's an outlier, this one. It cannot be one of the alkanes, because remember, this is a hydrocarbon. So it means you rather choose from A, B, and C. And after recalling all the information about this, you will know that your correct answer is C. Name of the functional group of alcohols, which is our second. So you see, in this case, you are provided different functional groups names. So it means it's a recall type of a question. That is why it is very important that you go back and recall those types of questions. So you know that alcohols use what? Hydroxyl group. So there's no way that you can know this without going back and studying whatever that we taught. Here it says, which one of the following compounds is an aldehyde? Remember, we use suffix or we use functional groups to identify compounds. So in this case, because we are provided names, we are going to use suffix in order for us to see which one is an aldehyde. And definitely, by using a suffix, you know that al is an aldehyde. So there are lots of questions whereby you will find recall questions, whereby you will sometimes need to work even further than that in order for you to get the correct answer. Now consider the following structure. The first thing that you look about this structure, you can see that this structure is having 2 oxygens. And what we know is that we only have 2 homologous series, whereby when we draw their structures or their functional groups having 2 oxygens, they are esters and carboxylic acids. So those are the only 2 homologous series where we have 2 oxygens in their structure. But now you need to check how is the structure drawn, and you can see that this one is an ester. Remember, we did esterification, which was the formation of an ester from an alcohol and a carboxylic acid in the presence of a concentrated sulfuric acid as the catalyst. So you always know which alcohol and which acid is responsible for that ester. And I always say, you know that this oxygen is always bonded with a C. You will always locate the other oxygen, which is going to be a boundary or a separator between the alcohol side and the acid side. So you can see that this one is having 1, 2, 3, and this side, because this part is coming from a carboxylic acid, is having 2. So you can see that this is coming from propan 1-ol. Why am I confidently saying propan 1-ol? Remember, all our esters are coming from primary alcohol. So you are not going to have a dilemma of choosing between propan 1-ol or propan 2-ol, because it will always be 1-ol for all the esters that we are going to do, that is why I'm saying we are using primary alcohols. And remember, the word primary alcohol, it also has a definition. So it means it's coming from propan 1-ol and ethanoic acid. And the correct answer is ethanoic acid and propan 1-ol. So all the options, if you can see them, sometimes they might confuse you because maybe you don't know how do you form an ester, but you definitely need to go back and check how is an ester formed. Now, as I'm saying that, I'm not going to go through all the questions, but some of the questions are going to be shared with you, because all the slides that we are using here at the studio, they are going to be shared with your teachers, and you're definitely going to use them, as you know that you have enough time to practice a chemistry, because you are writing on the 26th. So here they say the empirical formula. Remember, this is a grade 11 topic. This is a grade 11 concept. So if you can write the molecular formula of this 1,2 dichloroethane, you will see that your empirical formula will be number B. And you know how do you find the empirical formula. So I'm saying don't forget that concepts that are in grade 11, they are sometimes examinable in grade 12, like such concepts of empirical formula or stoichiometry that is coming from grade 11. Also, this one, I chose it because you can see that this structure, the way it was drawn not in a straight chain like a horizontal chain. It was drawn vertically. So you also need to be able to say this is the carboxylic acid by identifying what? The functional group. And also do what? Also identify the longest chain. So you can see that the longest chain will always start here. 1, 2, 3, and 4. You can see that the longest chain will always start at the functional group, because you cannot remove that functional group. Therefore, you can see that in carbon number 2 we have 2 methyls, and in carbon number 3 we have 1 methyl. So already you can see that we have what? We have 2, 2, 3 trimethyl. This is the longest chain is 4, so butanoic acid. So go back and check how did we do our naming in terms of different structures. Then we normally have our long questions, because what we're doing, it was just multiple choice. We know that when we're given a long question, the first thing that you need to do, you need to identify whatever that you are provided on the table for you in order to be able to answer questions. It is not always that when you are given carboxylic acid, there will always be a straight chain carboxylic acid. As you have seen on the naming that we have just done right now, you can see that we also sometimes have our substituents in those carboxylic acids. So go through them and check them thoroughly. The first thing says define a homologous series. You know those compounds with the same general formula, whereby the next member differs from the next member by CH2. You know those definitions. You definitely have to go back and check on them. And then the letter that represents saturated hydrocarbon, as I said, that you need to go back and check what are saturated hydrocarbons, which when you look at the entire table, there will only be one hydrocarbon, which is our pentane. And then the general formula of the homologous series to which C belong. Remember, they don't want what is C, but they want the general formula of C. And as we did the revision, you know that this is an alkene because of the triple bond, so it's going to be CnH2n minus 2. I don't expect that we're going to do everything that is here, but at least the things that I'm saying, they will remind you to say, what is it that I remember, what is it that I've already forgotten, in order for you to answer these questions. And then the structural formula of A, which is our aldehyde, which is Al, and we know that our aldehyde, the functional group is COH, and then it is having how many carbons? 3 carbons, whereby carbon number 2, it is having a methyl. So such things, as I'm saying, not always that you'll get a straight chain aldehyde or a straight chain ketone. Sometimes you can also include a branch. So these are the type of questions that you must remember as you're going to. Then the one that I'm interested in before I go to the next question is, they say compound D has 3 structural isomers. So if you look at compound D, you can see it's our pentane. So if you are saying our pentane is having 3 structural isomers, the first one is the pentane. The second one, it can be a methyl butane. Now they say draw the shortest, the structural formula of the shortest isomer. So you need to draw the structural formula of the shortest isomer. And because it's 5, it means it will be reduced up to 3. So you will see that you're going to have 2,2 dimethyl propane as your shortest, because 2-methyl butane will be the second one, but the shortest is going to be this one of 2,2 dash or hyphen dimethyl propane. And then You also need to look at the combustion reaction. Remember, we also assisted you to say how do you balance combustion reaction. This one was about pentane. So it was about, you know how to write already the molecular formula of pentane, because it's going to be C5 and then H25 plus 2, which is going to be C5H12. Go to the rules of how do we make sure that these hydrocarbons or alkanes react with what? With oxygen. Remember, oxygen is O2 and is our diatomic molecule. So the product is going to be carbon dioxide and water in all the compounds that you are going to be provided. Now, when coming to physical properties, which is our question number 3, I just designed this table so that we can compact everything in one form. You can see that our physical properties are only 3: melting point, boiling point, and vapor pressure. And also you need to know the strength of the intermolecular forces. So how does this the physical properties depend on the strength of intermolecular forces? How do they depend on the strength of the intermolecular forces? We are saying the increase in the strength of intermolecular forces, there will be higher boiling point, there will be higher lower vapor pressure, and also higher melting point. So we are just saying the stronger the intermolecular forces, the higher the boiling point, the higher the melting point, and the lower the vapor pressure. So if you know that the intermolecular forces are stronger, then you can conclude in terms of the 3 physical properties. Now, what is this strength depending on? Remember, the physical properties are depending on the strength, and the strength depends also on something. The strength depends on the chain length. So how is the strength depending on the chain length? We are saying as you increase the carbon chain, you are also increasing the strength of the intermolecular forces. So the longer the chain, the stronger the intermolecular forces. And you know, if you are saying the stronger the intermolecular forces, we already know that there will be higher vapor, there will be higher boiling point, there will be higher melting point, and there will be lower vapor pressure. So it means the longer the chain, the lower the vapor pressure, but the higher the boiling point. And then when you look at the chain, when you're comparing the chain, you must only compare the chain of compounds of the same homologous series. It means I cannot compare the chain of ketones and alkanes. If I have to compare the chain, I must take the chain of all the alkanes. It must be maybe methane, ethane, and propane. They must all belong to the same homologous series, because the only independent variable that I will be having, it is the chain length. And then if I'm looking at the surface area again, it will also be compounds of the same homologous series, because the only thing that I'm doing there, I'm just reducing the surface area. Like for example, if I'm taking butane as my compound, and then I'm comparing the boiling point of butane and 2-methyl propane. What you know about butane and 2-methyl propane is that they are chain isomers of each other. So what I'm keeping constant is the mass. So what is going to happen is that I will know that butane will have a higher boiling point than 2-methyl propane. However, 2-methyl propane will have a higher vapor pressure than butane, because it means the intermolecular forces of 2-methyl propane will be weaker than those of butane, because we are saying the longer the chain, the stronger the intermolecular forces. The larger the larger the surface area, the stronger the intermolecular forces. The smaller the surface area, remember the surface area is smaller or larger, and then the lower the boiling point. But now the boiling point, remember, is an opposite of vapor pressure. Also, the melting point is the opposite of vapor pressure. We also need to talk now, when you are comparing, there are things that you need to mention in order for you to be able to compare. Number one, you will compare your independent variable. You will tell us what is different about the structure. And then number two, we'll talk about the strength of the intermolecular forces. The intermolecular forces are written in full, intermolecular forces. And then you need to also talk about the energy needed to overcome those intermolecular forces. So before you start comparing, you start by saying what makes the structures to be different, and then what can I say about the strength of the intermolecular forces, and then what can I also say about the energy needed to overcome those intermolecular forces. Then when they are belonging to a different homologous series, now what you are comparing, you can compare the type of intermolecular forces. And we have 3 types of intermolecular forces that are examinable for our grade 12 2023. We have our London forces, which are the weaker forces. We have dipole, which are the middle one, and the hydrogen bonds, which are the strongest. Now you need to also remember that as we are saying these compounds belong to, they have London forces, we mean everything that you see here, all the homologous series will have London forces. However, when coming to dipole, only the aldehydes, the ketones, the esters, and the alkanes will have the dipole, and then hydrogen bonds will be only the what? The alcohols and the carboxylic acids. And we know the difference between the hydrogen bonds of alcohol and carboxylic acid. Alcohol have one side of hydrogen bond, and carboxylic acids have two sides of hydrogen bond. Therefore, you know that it means the carboxylic acids will be the ones that are having the strongest intermolecular forces as compared to all the homologous series. Now, this is what I said you must remember when you answer the questions under physical properties. Say what is different about the structure, and say the effect on the intermolecular forces as you are discussing your differences, and also the energy needed to overcome those forces. Remember, we are doing question number 1 up to question number 9. It might seem that our topic is very quick. However, as you are going to go through this recording after this live recording, you can still go back and rewind and pause where you don't understand, because definitely everything will be done rush because of time. Now, so I stated our dependent variables under question number 3, they are our physical properties, that is boiling point, melting point, and vapor pressure. And what is our independent variable? What are we gonna change in order to check the effect on the boiling point or the melting point of the vapor pressure? Is the chain length, is the surface area, and the type of intermolecular forces. Sometimes you can say branches are part of the what? Of the surface area, because as you are branching, like the example that I gave of pentane and 2-methyl butane and 2,2 dimethyl propane, you can see that 2,2 methyl dimethyl propane, it is the one that will have the lowest boiling point, but will have what? The highest vapor pressure, because of the more spherical the structure is, or more compact the structure is. So you already know that the more you branch a substance, the more you are decreasing its boiling point and melting point, and what you're gonna increase is the vapor pressure. Now, when we look at our multiple choice questions under this topic of question number 3, which is our physical properties, the first question says, which one of the following compounds have the lowest boiling point? Already you know what is a boiling point, because the definitions are the first thing that we're gonna do. You know what is the boiling point, you know what is the melting point, and the vapor pressure, and you've been memorizing the definitions. We also encourage you to record yourselves as you are saying the definitions. So already you know that if you are given different homologous series, these are the alkanes, aldehydes, alcohols, and also this one is an alkane. So it means here the issue is about the type of intermolecular forces. That is the first thing. It's about the type of intermolecular forces. So you can see that lowest boiling point, it must be between this alkane and this alkane, because these two, they have London. This one is having a London. This one is having dipole, hydrogen bond, and again this one is having London. So it means now we are comparing between alkane A and alkane D. Now, what is the difference about alkane A and alkane D? The independent variable is the what? Is the surface area. This one is methyl propane, this one is butane. So when you draw the structure, you know that what will make them to be different is the surface area. So we know that the larger the surface area, the stronger the intermolecular forces. The lower the surface area, the weaker the intermolecular forces. So if the intermolecular forces are weaker, it means the structure will have what? The lowest boiling point. So that is why number D is our correct answer. But remember, the possibility was between A and D, not C and B. Which one of the following compounds will have the highest vapor pressure? We know that now we are expecting a compound that is having weaker intermolecular forces. And when you look also at the structure, all the same if the compounds are provided, but now we want the highest vapor pressure. If if we set is the lowest boiling point, definitely it must also be what? The highest vapor pressure, because the vapor pressure is the opposite of what? Of the boiling point. So don't be confused by saying highest vapor pressure and think about stronger intermolecular forces. Highest vapor pressure means there is a weakest intermolecular forces. I'm just writing IMF because of time, but during examination, we don't expect you to write IMF. You must write in full intermolecular forces. Then this one, it says, let me just do this one, the last multiple choice. It says compounds in the same homologous series. So you need to know what makes the compound in the same homologous series different or the same. They say they have the same boiling point. Definitely it's not going to be possible, because the more we change the size of a compound, the more the boiling point and the vapor pressure and the physical and the melting point will be affected. So this one is incorrect. They have the same functional group. Definitely we know that the functional group describes a homologous series, so it can be correct that they will have the same functional group. They have the same molecular formula. This is also wrong. What is the same about them is the general formula, not the molecular formula. So the only correct answer is number 2. And when you look at our options, is only number A. This one, I just want us to look at it because it's a graph, and the statement is also sometimes confusing. They are saying the relationship between the boiling point and the number of carbon atoms in a straight chain molecules of aldehydes, alkanes, and primary alcohols is investigated. Curve A, B, and C are obtained. Which compound are represented by curve B? Now, when you look at curve A, B, and C, they are representing different homologous series of different compounds in that homologous series with different chain lengths. So you already know that alcohols, as they are part of the compounds that you are comparing, they will always have the highest boiling point as compared to any other group that is given on this table, because carboxylic acids are not given. So if alcohol is there and carboxylic acid is not there, so alcohol will definitely take the preference in terms of the strength of the intermolecular forces. So you can see that A will represent the higher boiling point, B followed by B, and C the lower. So you need to immediately say which graph represent alcohol. So definitely alcohols will be represented by A. But now, what will represent aldehydes? You know that aldehydes are having dipole forces, which are weaker than hydrogen bonds but stronger than London forces. So that is why you will say B represent our aldehydes, because B is between the London forces and the hydrogen bond. So curve B is the one that represents what? Aldehydes. So don't be afraid to go and try and interpret the graph, because always the graph will be given the information. Then here they say IUPAC name of a compound with the boiling point 373. If you look at our 373, this is the boiling point and it falls under the aldehyde. So the aldehyde with 4 carbon atoms, we know that is our butanol. So that is the only thing that the examiner wanted to see, whether you can be able to interpret the graph. Now, when you look at this is a long type of a question of question number 3. The graph below shows the boiling points of a straight chain primary alcohols and straight chain ketones with different number of carbon atoms. It's almost the same as the previous question that we did. So they are showing you the graph that represents alcohols and the graph that represents the ketones. The first thing the examiner says, define boiling point. All learners in Gauteng, they must be able to get this mark, because you are going with this mark as the memorandum, because you know that definitely one of the 3 physical properties might be as one of the definitions. Explain why the boiling points of alcohols increase as the number of carbon atoms increases, by referring to the type and the strength of the intermolecular forces, which is 2 marks. We know that the type of intermolecular forces of alcohols is hydrogen bonds. So the longer the chain, the stronger the hydrogen bonds of the alcohol, because the longer the chain, the stronger the intermolecular forces. So what they will comparing here is the chain length, because we are referring to the same homologous series. Then explain why the curve of alcohols is higher than that one of the ketones. Refer to the type of intermolecular forces and the strength of the intermolecular forces. So these are the bullets that I said we need to make sure that we write as we are going to answer this question. First of all, what is different about alcohols and ketones is the type of intermolecular forces. So you can start by saying alcohols have what? Have hydrogen bonds, and ketones have, so you can write in bullet form, have what? Have dipole forces. Then the next thing is about the strength of intermolecular forces. So now we are comparing between dipole, and hydrogen bonds. So what you know is that hydrogen bonds are stronger than what? Hydrogen bonds are stronger than dipole forces. Therefore, more energy will be required to do what? To overcome, the hydrogen bond. So this is how we want you to write it in bullet form. Hydrogen bond of alcohols than dipole forces. So you are just telling us what makes the two structures to be different. And they say the type and the strength of the intermolecular forces. Now the vapor pressure of the alcohols is compared to that of the ketone. So you know, the stronger the intermolecular forces, the lower the vapor pressure. So we'll definitely expect that whatever that will be asked in question number 3.4 to identify that factor that shows that now the ketones will have a higher vapor pressure because they have the lower boiling point as compared to what? As compared to alcohols. Okay. The next thing that we also do under organic molecules, which is our question number 4, we do organic reactions. Now, organic reactions are given to us as number 1, combustion, that we just talked about, and it's the combustion of alkanes only, which is going to be the reaction of alkanes with oxygen. The only thing that you must be worried about is balancing, because the products are obvious, is carbon dioxide and water. And we also talked about esterification, which is another organic reaction between carboxylic acids and alcohols, whereby we need concentrated sulfuric acid as our catalyst. And then the other reactions will be addition reactions. Now, under the addition reactions, we have 4 types of addition reactions. We have an addition reaction where we add hydrogen, and we call that hydrogenation. And the condition is that you need a platinum as your catalyst, as it is provided here. So we know that when we are doing addition reaction of hydrogen, we are going to get alkane as our product, because we only do addition reactions of what? Of alkenes. And then we have an addition reaction that is called halogenation, where we add what? Halogens, and we get haloalkanes. And also hydrohalogenation, where we are going to add what? Where we are going to add HCl or HBr. Just go back and look at those. Then the conditions of hydrogenation, because I think of halogenation, is that we need an unreactive solvent, and we need also an alkene, so that we can produce what? So the product that is expected and the type of reaction and the condition, they are provided on the slide. Just go back and look at all the conditions that are needed in order for you to be able. Now, the hydrohalogenation, the condition is that you don't need water, because it's the reaction of hydrogen, hydrohalogen, or hydrogen and halogen with an alkene again to get a haloalkane. Then, in this case, you will see that a haloalkane will be formed. But now, when you look at halogenation and hydrohalogenation, the difference between the haloalkanes is that one of halogenation will have 2 halogens, and this one of hydrohalogenation will have only 1 halogen. And then the last one is hydration, where we are forming an alcohol from an alkene. We will need also here sulfuric acid as what? Excess water, and small amount of what? Of sulfuric acid as a catalyst for this reaction to occur. And definitely we are going to get our product as what? As water. So that is why we don't need water here, because you will end up getting an alcohol instead of what? Of getting a haloalkane. We also do substitution reaction. Remember, the substitution reaction is that one of alkanes to haloalkanes, the alcohols to haloalkanes, and the haloalkanes to alcohols. So just go back and look at all those substitution reactions. This one is an example of that one of alkanes forming what? A haloalkane. And you can see that substitution occurs only once. If you substitute with one Br here, the other Br will joining the H that is substituted from the other. Then what do you need for substitution? You will definitely need sunlight for such kind of substitution. And then we also did elimination reactions, whereby we were forming alkenes in most of our reactions, and there were also reaction conditions in terms of those reactions. I'm not going to go through all the reactions, but as we are looking at the questions, maybe we can remember what is it that we're expected to do. Now they say name of the catalyst needed for esterification. I already discussed the catalyst for you, which is sulfuric acid. Remember, the condition is that it must be concentrated. And then remember, hydrolysis reaction is when a haloalkane, just to remind you, a haloalkane form what? Form an alcohol. But now, what are the conditions? The conditions is that you must have another reactant, which is what? I normally say a diluted sodium hydroxide, because they say a diluted strong base. So if you say sodium hydroxide, you already know that it's a strong base, so you can use it. And you also need mild heat. So these are the two conditions of substitution reaction, which is hydrolysis. And it's always one direction, from haloalkane to alcohol. Then from alcohol to haloalkane is just substitution, is not hydrolysis, because water is not involved in that reaction. Then we know that if we want a hydrolysis reaction, this haloalkane must change and become what? An alcohol. So you check on your options. The only option that is an alcohol is ethanol, and definitely is bromoethane. So bromoethane, when you write it, you will write it as like is the Br and then H, 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 and H. And then when you substitute where there was a halogen, you will put what? An OH. That is why you find what? Your ethanol. This one is the test for saturation, because they talk about the decolorization of bromine water. So we know that bromine water will decolorize quickly when we are using an unsaturated hydrocarbon, when you mix it with it or when you make it to react with it. So what will make this to decolorize quickly is normally an alkene, because we don't do reactions of what? Of alkynes. So you just check which one is the alkene here, and you can see that is A. Remember, we also did elimination reactions. So our elimination reactions are dehydration, where we remove water, are dehydrohalogenation, where we remove a hydrogen halide, and also the dehalogenation and dehydrohalogenation. Hydration. Okay, fine. So sometimes the examiner will give you conditions like this. What you must know is that if you are using a diluted strong base, it means the type of reaction is substitution, and the type of substitution is what? Is hydrolysis. But now if your strong base is concentrated, the type of reaction now is no longer substitution, but is what? Elimination. Go back and look at those conditions, because they are very important. And here we also need heat, but now we need high heat. Here we need mild heat. So go back and look at those conditions. So already you know that reaction 1 is a substitution reaction. Reaction 2 is an elimination reaction. The only thing that you just need to ask yourself, what are we eliminating? What are we substituting? So we are given a compound P here, which is C5H11Br. It forms 2-methyl-butane 1-ol. Already the product that is formed is having a branch. So it already tells us that if you are forming a product that is having a branch and you are doing substitution, it means even your original compound was a branch. So that is why here, when you go back and try and draw the structure of compound P, it's not going to be a straight chain, a haloalkane, but it's going to be a haloalkane, which is what? Which is having a branch. So it's going to be 1, 2, 3, 4. In carbon number 1, we'll have what is it? OL. So it means our Br will be also in carbon number 1, because we are doing what? Substitution reaction. And then we are told that in carbon number 2 is a methyl. So go back and draw the same structure and see if you can get that name. So it means our structure is going to be it's going to be 1-bromo, 1-bromo, 2-methyl, and then what? Butane. So already you can see that it's not a straight chain, a haloalkane. And also here you will expect an alkene, of course, because this is what is elimination because of the condition. And then here, because here we are having an alkene, you will expect what? An addition reaction, because all alkenes will undergo what? Addition reaction. So they say IUPAC name of compound P. Already we know that from the compound that is our alcohol, we know that our compound P is 1-bromo, 2-methyl butane. So the correct answer is going to be B. We are going to take just a 1-minute break. When we come back, we're going to continue with our question number 5, which is our rate of reaction. I'm going to question 5. May I jump in? Welcome back, grade 12s. I know this is a rushing session, and I can see even from your comments that you are saying amen. Just try to slow down. However, if we want to complete all the topics and we try to remember all the topics, we will try to be slow. But remember, you can also go back to this recording and rewind where you didn't understand some of the concepts. So let me just look at this one long question under the organic reactions, because I know that organic reactions are normally not friendly to us as we want them sometimes to be, because they are given as a flow diagram most of the time, or as weights sometimes. So they're saying here we have compound P that can be used to prepare organic compound R and Q as shown on the diagram. So we are using our alcohol P, and then we are preparing a haloalkane Q, and then in the presence of a concentrated sulfuric acid, we are going to prepare our compound R. So from this, you can already see the type of reactions that you need to identify, because if you are moving from an alcohol to a haloalkane, remember our triple S, SU, USA. So it's from a saturated compound, which is alcohol, to a saturated compound, which is a haloalkane. So already it tells us that this is our substitution reaction. So we know that for our substitution reaction, we need an acid with an alcohol so that we can get that haloalkane that we need, that halogen that we need in order to form what? To form a haloalkane. Now, our haloalkane, we don't know the name of the haloalkane. We also don't know the name of the alcohol. We also don't know the number of carbons that are in each. However, when you look at reaction 1, the alcohol will react in the presence of concentrated sulfuric acid to form compound R. But we are given the name or the formula of compound R. And when you look at compound R, you can see there are 2 oxygens, as I said. So this is our ester. So already we know that it means for this compound R to be formed, this alcohol reacted with what? With a carboxylic acid. So there were 2 compounds that were involved for us to get this compound R, which is our ester. Now, I said we're going to use this oxygen as our boundary to separate the 2 sides. And you can see that now with this CO bond is on the side of the oxygen. So already you can see that there are 1, 2, 3 carbons that are coming from the alcohol, and there are 2 carbons that are coming from the carboxylic acid. So now we know the name of our alcohol. It means our alcohol is having 3 carbon chain, and we know that this is formed by our primary alcohol, so we know that this is propane 1-ol. And if we know that this is propane 1-ol, it means we will also know that our haloalkane is going to be what? 1-chloropropane, because our chlorine will replace our OL, our hydroxyl group, and then we are going to find 1-chloropropane. So by just looking at the ester, we can go back and identify back our alcohol and also get what? Our haloalkane. So we know that this is substitution reaction and this is esterification, because it's the formation of what? It's the formation of an ester. Now in reaction 1, alcohol P reacts with another reactant or another organic compound in the presence of concentrated sulfuric acid. We have already identified that, because we said if an ester is formed, we know it's coming from a carboxylic acid and an alcohol. And the examiner is also saying there is another organic compound that they are going to use for reaction 1. Besides the presence of a catalyst, write down another reaction condition for this reaction. Okay, let me start by saying name the type of reaction. So we know the type of reaction for reaction 1 is esterification, the formation of an ester. Then, beside the presence of a catalyst, which is our sulfuric acid, write down another reaction condition. We know that for esterification, as some of you did this practically in your class, you also did what? You also heated the mixture. So we also need heat for this reaction as one of the conditions for esterification. Then we want the structural formula of compound P. Remember, compound P, we have already identified it as our propane 1-ol, because esters are formed from primary alcohols and carboxylic acid. So the structural formula is going to be the propane 1-ol. We can draw it in any way, but we must know that the functional group must be in carbon number 1. IUPAC name of R. Our R is our ester. So we know that it's coming from propane 1-ol and ethanoic acid. So it's going to be what? Propyl, and then what? Ethanoate. Because this part comes from the carboxylic acid and this part comes from the alcohol. And then the IUPAC name of the strained functional group of this isomer R. Remember, the functional isomers, we only have 2 pairs. Is esters with carboxylic acid, is ketones with aldehydes. So when we are moving from a carboxylic acid to an ester, you might sometimes have many different isomers depending on the chain length. However, when we are moving from an ester to a carboxylic acid, you just count the number of carbons that the ester is having. Like in this case, there are 1, 2, 3, 4, 5 carbons. So if there are 5 carbons, we don't have positional isomers in terms of the functional group in carboxylic acid. So they will always be in one, like propanoic acid, methanoic acid, ethanoic acid, because it's a straight chain, there is no branch. So we already know that there are 5 carbons. So this is going to be what? So they want the name. So this is going to be what? The 1, 2, 3, 4, 5, the pentanoic acid. Please don't forget that the word acid is part of the IUPAC name, and you must never ever leave the word acid as you are writing the carboxylic acid. Here we are having alcohol P again with the same structure as the previous one, because I just took it so that we can refer to it. For reaction 2, this is our reaction 2, which we have identified as our substitution reaction. So they say the type of reaction that takes place, already we have identified it as a substitution, because we know that it's from a saturated to a saturated compound. And then the formula of the inorganic product. Now, because this is substitution reaction, how does it occur? Remember, our propane 1-ol is 1, 2, 3. We know it's propane 1-ol, and we are doing the substitution reaction. And then it's propane 1-ol. Let me put OH here. We know it will react with what? Which HCl, which is our inorganic compound. So what was there as our OH will now substitute with what? With Cl. So it's going to be 1, 2, 3. So where there was OH, I'm going to put my Cl and H and H and H and H. Make sure that you always write the number of carbons. Now, remember I have replaced OH with Cl. So OH will now be left stranded. So what is going to happen? OH will just combine nicely with H that was also left when I was doing substitution. And I will get what? I will get water as one of my products. So it means the inorganic product that will form during this substitution reaction is also what? Is also water as my inorganic product, because it is the one that was formed from the OH of the alcohol and the H of the inorganic reactant. And then the condensed structural formula of compound P. Compound P, remember, is our haloalkane. We have identified it as what? 1-chloropropane. So it is the condensed structure. You just say how many or what is it that is bonded to each carbon, which is going to be CH3 and then CH2, and then we can say CH and then Cl or ClCH. It doesn't matter. You just say what is bonded to each carbon. So you need to know how do you do your addition reaction. You need to know how do you do your elimination reaction and also your substitution reaction. But don't forget that sometimes you'll find that, especially during addition reaction, everything is added and you only find one compound as a product. But in substitution or elimination, you can find multiple number of inorganic products that might be formed during that reaction. Unlike in the case whereby we having cracking. Cracking will always give you organic compounds, but what it will do, it will give you one alkene with other alkanes, because we are saying is when we are forming a more useful molecules from a larger molecule, because cracking is when the process whereby a larger molecule is broken down into smaller useful molecules. So this is what the examiner expected from us in this question. I want to do this because it's a different type of reaction and is elimination. They say a primary alcohol contains 3 carbon atoms, is converted into secondary alcohols in 2 steps. The process is shown on the flow diagram below. So we know that we have our primary alcohol. So it means if it is having 3, it means it's our propanol, and then it undergoes step 1, and then it's gonna form what? Q. From Q, it must form a secondary alcohol. And we know that the only way we can form a secondary alcohol is when an alkene undergoes addition reaction, which is addition of water, which is hydration. So we will expect from here to here to have what? Elimination reaction, so that we can have an alkene. And then from here to here, we expect to have what? To have again addition reaction, so that we can have what? An alcohol. So you need to know, how do I make some means for me to go from primary alcohol to secondary alcohol? P is an inorganic reactant, while Q is an organic compound. So P alcohol, primary alcohol react with P in order to form Q. Now, what is the elimination reaction whereby an alcohol form an alkene? We know that during the process whereby we added water in an alkene, we formed an alcohol. So when we remove water from an alkene, we are going to from an alcohol, we are going to find an alkane. And in that moment, we will need sulfuric acid. That's one of the reactant for us to remove water from the alcohol. So the alcohol will react with sulfuric acid in order to get what? To get a water out of the system. So we are going to use sulfuric acid. They say formula is going to be H2SO4. Remember, if you write sulfuric acid, it's going to be incorrect because the examiner said you must write the formula. And we know that most of our dehydrating reactions, they will definitely need what? Sulfuric acid. One reaction condition for reaction, one reaction condition for the reaction in step number 2. Step number 2, remember, is when we are moving from an alkene to what? To an alcohol. So we knew that we need what? Excess water for this reaction. And we also need what? A small amount of what? Of sulfuric acid as the conditions for our hydration. So we know that the one of the conditions, you can write this one excess water, because we need more water for the water to react with an alkene in order to form an alcohol. Why will it be a secondary alcohol? Remember, the alkene that will be forming at Q is going to be having 3 carbon, and it's going to be what? Propene. So how does propene become a secondary alcohol? Propene, SC double bond C, C, H, H, H. What is going to happen to it? We are going to add water into this propene. And when we add water, we know that during addition reaction, the double bond will be broken. So when the double bond is broken, we expect H, and then a missing bond, CH, and a missing bond, and then CH3. So this one is fine. So we need to add the H and the OH in this alkene. And we know that according to Markovnikov rule, the hydrogen with the carbon with more hydrogen will take the hydrogen, and then the OH will go here, and this will gonna be our secondary alcohol, which is what? Propane dash 2 dash all, not prop 2 all, but propane, because it was supposed to be propanol. So propane 2 all is gonna be formed from this step. And then a balanced equation to show the reaction, which is reaction 2. And I've already done that. I've shown how we move from that propene, which is our alkene, to the alcohol. When we look at question 5, it is starting from grade 11 knowledge, which was energy and change, where we look at exothermic and endothermic graphs. They are still very much examinable. Go through them, see how they differ in terms of the shape. Also know the labelings on each of the graph, the activation energy, the activated complex, and the meaning of each and every term. Like in this case, we gave the meaning of activation energy, and we said is the minimum energy needed for the reaction to take place. And we also talk about that unstable transition state from reactants to product, which is known as activated complex. So go back and check those energy and change graphs in terms of the rate of reaction, because they will be asked under question number 5, which is our rate of reactions. Also on the rate of reactions, we are going to look at the factors that affect the rate of reactions, but you are not going to be expected to list them. You are going to be expected to use the collision theory for you to explain how does each factor affect the rate of reaction. So what are the conditions for the reaction, which is what is very important? The conditions for the effective collision. That is why we are using what? Collision theory. We are saying we need minimum energy that is equals to or higher than activation energy for any reaction to occur effectively. And we also need correct orientation of the reacting particles for the reaction to occur, because there must be the rearrangement of particles for us to form what? To form a product. So those are the 2 conditions of effective collision. We need energy that is equals to or sufficient for the reaction to occur. So we need to also explain in terms of the collision theory, how does each factor from the 4 factors, because I'm just going to exclude the nature of reacting substances, how does each factor affect the rate of reaction? So the first one that we can look at is the temperature. Go and check how does temperature affect the rate of reaction. The temperature, what does it do? It increases the average kinetic energy of reacting particles. That is the only thing that the temperature will do. And immediately when it increases the average kinetic energy of particles, there will be more particles which have what? Sufficient energy, sufficient kinetic energy. And then for that reason, there will be more effective collision per unit time, and then the rate of reaction will increase. Now, when you get plate number 2 and number 3, more particles will have sufficient energy. Sometimes we say which is equals to or greater than activation energy, and more effective collision per unit time. It will be the bullet that is found in all the explanations that we are going to do. It will be the bullet that will be included in all the explanations that you're gonna do. Temperature, concentration, surface area. You need to have these bullets with you in order to get the 2 marks. So already as you are going to the exam room, you are going with the 2 marks of more particles will have sufficient energy that is equals to or greater than activation energy. You are also having more effective collision per unit time. Then the only thing that will be different is going to be the first bullet in terms of now you know how does each factor differ from one another. So temperature, it does what? It increases the average kinetic energy of particles. And immediately I just reminded you with the Maxwell-Boltzmann curve or Maxwell distributing curve. When you look at curve T is when we are having lower temperature. However, curve T2, so it's T1 and T2. So this one is where we are having a higher temperature. The graph becomes shorter. It's at the bottom, it's below the first one and towards the right hand side. So it's below towards the right hand side. Smaller, lower temperature, higher. So here it shows that there are more particles with sufficient activation energy. So normally the examiner will give you one graph and say, draw on the same set of axes, draw the graph that indicates higher temperature, or but we only look at the factors that increase the rate of reaction. So there is no way that you will draw a graph that shows a lower temperature. It will always be about the higher temperature because we look at what increased the rate of reaction. So this is the graph that represents how does the particles are going to be distributed in terms of when you change the temperature, when you increase the temperature, by doing what? By increasing the average kinetic energy of particles. Then this one is about the catalyst. So what does the catalyst do to affect the rate of reaction? Remember, rate of reaction is what? Rate of reaction is the only a definition that you're going to get in question number 5. And all the factors are trying to increase what? The rate of reaction. So by so saying, I can just say rate of reaction is our dependent variable for question number 5. So this catalyst will do what? It will provide the alternative pathway of lower activation energy. So what does it do? It provides an alternative pathway to do what? To lower the activation energy. Remember, the next two bullets are the same. There will be more particles with sufficient energy that is equals to or greater than kinetic energy, and there will be more effective collision per unit time. So that is what the catalysts do. So you can see that it has now done what? It has lowered the activation energy of the reacting particles. Then the concentration. What does the concentration do? The concentration, it just only increases the number of particles or the number of reacting particles. When you look at the two graphs A and B, A represent higher concentration, B represent lower concentration. So when you increase concentration, you are increasing the number of reacting particles. So both graphs will start at the same point and end at the same point. But the one with a high temperature will be above the one with a low temperature. So there will be more particles that will have the sufficient energy for effective collision, and there will be more effective collision per unit time. So always I said bullet number 2 and number 3, they are our memorandum to the exam. Also the surface area. The surface area, what does it do? It makes sure that there are more reacting sites. It allows more reacting sites of the particles. So it doesn't increase the number of particles, but it does what? It allows more reacting sites in those particles, and therefore there will be correct orientation for the particles to react, or there will be more particles with enough energy that is equals to or greater than activation energy, and there will be more effective collision per unit time. So just know that there is no way that you're gonna list the factors, but you need to remember how do you use collision theory to explain each and every factor. Now, this is the rate of chemical reaction can be expressed in, remember, rate of reaction can also be calculated, and rate of reaction can be calculated in terms of, we say in terms of the rate of reaction is equal to rate of reaction is equal to change in concentration over change in time. So it can be the change in concentration of the reactants or product per unit time. That is the definition of rate of reaction, is the change in concentration of reactants or product per unit time. So we can calculate it in terms of concentration, we can calculate it in terms of moles and say mole per second, or we can say grams per second, or we can say decimeter cube per second. We can calculate it in different ways, looking at the volume, looking at the number of moles, looking at the mass. We cannot calculate it as grams per mole. Remember, what we calculate as grams per mole is the molar mass. Therefore, the energy consumed. So the only thing that we need is the volume of a gas per unit time. So it's grams per seconds. So we know that we only look at the rate of reaction in terms of the calculation. The calculation are stoichiometric calculations, which can be found in any other question, because this is all about energy and change. So the correct answer is going to be only number C, because it's about the volume of the gas formed per unit of time. Then this one, it was trying to give us the definition of reaction rate. When you look at it, it says the rate of reaction, chemical reaction is mostly correctly defined as time taken for the reaction to occur. Definitely is not, we know, is the concentration of the product, is the change in concentration of the product or reactants per unit time. Also, it's not about speeding up the reaction. Now, when you look at this one, is the change in the amount of reactants or product. But remember, there is no per unit time. So definitely this, what makes it to be wrong is that per unit time is not included, because the word per unit time is very important as we are going to explain your definition. These are type of the long questions that you can find in question number 5. Here they are giving you the statement. As you know that the statement will always give you the clue about the question. The reaction between sodium thiosulfate and excess hydrochloric acid is used to investigate the effect of concentration and temperature of the rate on the rate of reaction. So you know how does the concentration and the temperature affect the rate of reaction. You can also use the collision theory to explain how will the particles react as you increase the temperature or the concentration. So you are provided the balanced equation, and then we're provided with an Erlenmeyer flask, which is having a sodium thiosulfate, and they are saying the disappearance of the mark X, because there's the mark X that is put on top of the white paper, is measured according to the table below. So the same volume of sodium thiosulfate solution was used for all the reactions. Remember, our reactions must always observe fair test. So if you are differing the volume, you're gonna have many variables, and you will end up mixing your results. The table below shows the reaction conditions. Now we have experiment 1, experiment number 2, and experiment number 3. We are provided the concentration of sodium thiosulfate in all the experiments, the concentration of the excess hydrochloric acid, the temperature, and the volume. Remember, the volume is kept constant, and also the concentration of the thiosulfate is kept constant. Now they say write down the name of the independent variable for comparing of experiment 1 and 2. Remember, independent variable is what makes the two experiments to be different. So when we look at experiment number 1 and number 2, you can see that they have the same concentration of sodium thiosulfate, but they have different concentrations of HCl. They have the same temperature and they have the same volume. So the only thing that is different is the concentration of HCl. So our independent variable here is going to be what? The concentration of the HCl in the two experiments. How will the amount of sulfur formed in experiment 1 compare to that amount of sulfur formed in experiment 2 at the completion of this? Remember, because we are saying concentration, how does it affect the rate of reaction? It increases the number of particles. So we are expecting that experiment 1, because of higher concentration, to have what? To have higher, the production of sulfur to be higher than that one of experiment 1, because of what? As you are increasing the concentration, you are increasing the number of colliding particles. So therefore, there will be more effective collision per unit time. Then which experiment 1 or 3 is represented by curve T2? Remember, this is a Maxwell-Boltzmann distributing curve, and we know that it represents what? It represents temperature, because we discussed the shapes of each and every graph. So when you look at experiment 3, you can see that experiment 3 now is saving 40 degrees, whereas degrees Celsius, whereas experiment 1 is saving 25. So you expect that experiment 3 will have a higher temperature. And when you look at the two graphs, okay, let me just go back. When you look at the two graphs, you know that T2 represent what? Higher temperature. So therefore, they say here which experiment 1 or 2 represent T2. So you will already you know that where there was higher temperature, it was experiment 3. And explain your answer here in 5.4.1 are referring to the collision theory. So as I said, you need to know how does each factor affect how each factor affect the rate of reaction in terms of collision theory. So what are we talking about here? We are talking about the temperature. So the first thing we need to say, what makes the temperature, how will the temperature affect the rate of reaction? It will do what? Increase the number of reacting particles so that they will be effective, so that there will be more particles with energy sufficient, which is greater or equals to activation energy, and there will be effective collision per unit time. We are using bullets, so we must make sure that as we are using bullets, number one, it must be the vector. Number two, it must be about the particles, more particles that will have energy that is greater than or equals to the activation energy. And number three, it is more effective collision per unit time. So they say here, sketch the graph that shows the lowering of activation energy. You can mark it X. You know that when you are lowering the activation energy, that will be your X. And then, because remember, it provides an alternative pathway for the reacting particles. So just look at the catalyst graph where you have a high reaction rate and also where you have a low reaction rate. In question number 6, which is our chemical equilibrium, we are looking at the definitions like the closed systems, the open system, the homogeneous reactions, the heterogeneous reactions. Go back and look at those definitions. And also, we need also to state Le Chatelier's principle, which is 2 marks. The Le Chatelier's principle is provided to you on the exam guideline. Just make sure that you define it the way it is required to be defined. Because sometimes learners will ask, what if I define it like this? Remember, it's not about the way you feel you want to define it. It's the way the examiner also wants you to define a specific concept. So definitely we need to make sure that we define the Chatelier's principles correctly. This is where we are also going to do the KC calculations. And I'm saying that we are not going to put units for our KC calculations. It's not that KC doesn't have units, but we are not going to put units for the various reasons that we are using for these calculations. And that's where we apply our stoichiometry from grade 11. And also the meaning of KC value must be known and also explain in terms of the reaction that will be favored in terms of Le Chatelier's principle. So go back to those examples that you did under KC and look at how were you explaining such concepts. So this is all the concepts that are needed for us to be able to do this, including the graphs. Remember, the graphs are about the Le Chatelier's principles, about the disturbance at equilibrium. So they are also going to be inclusive as you are preparing yourself for the question number 6. Now, this one is just a simple recall type of a question which says, which one of the following represent a homogeneous equation? Remember, homogeneous is when all the faces are the same. Heterogeneous is when there is a variety of faces. So if you can look at reaction 1, the first equilibrium, all the reactions, the faces are the same. So we can say it's homogeneous, but otherwise the rest of the reactions provided here, they are heterogeneous reactions or heterogeneous mixture. So just go back and look at those concepts in terms of question number 6. And then this one, let me just go back to this one. Okay, this one was also talking about. Now here they are saying the balance equation of three reactions in equilibrium was given. In which reaction will the equilibrium position shifts when the volume of the vessel? Remember, this one is about to tell us how does the increase in volume. I know that you are saying volume is not the factor, but where there is crisis, when you increase volume, you are doing what? You are decreasing the pressure. When you are decreasing the volume, you are increasing the pressure. And which side will be favored by the increase in pressure? We know that the increase in pressure will favor the side with what? With less number of moles, and the decrease with the side which is having more number of moles. So remember, how does each factor affect the equilibrium in order for you to be able to answer such questions. Also, in terms of the concentration, when the concentration of the one reactant increase, the concentration of the other reactant decrease, so that the fourth reaction can be favored. So just go back and look at how did we deal with Le Chatelier's principle in order to look at how will different factors affect the rate of reaction. Now, when you look at this question here, because this is the one that I wanted us to do, which is 6.2. 6.2, it says 3,01 molecules times 10 to the exponent 23 molecules of nitrogen tetraoxide are sealed into 4 cubic decimeter container and then heated at 400 kelvins. The following balance equation represents the reaction that reaches at equilibrium at 400 kelvins. Now here is the reaction of nitrogen tetraoxide to give you 2 moles of nitrogen dioxide. Now they say at equilibrium it is found that 0.4 moles of nitrogen tetraoxide have decomposed to this one, to nitrogen oxide. Calculate the equilibrium, the Kc. Now what was making this question not to be as friendly as other questions is that here you were provided the number of molecules, and from the number of molecules, you are supposed to determine the number of moles. And how do we determine the number of moles using the number of molecules? We know that N is equal to N over Na. This is our Avogadro's constant. So the only thing that was making this question to be not as comfortable as other is because of the number of particles that were provided. If you have forgotten about how do you find the number of moles when you are provided the number of particles. However, you know that you are going to use your Avogadro's number to find the number of moles. So initially we have 0.5 moles as you found them from your Avogadro's number when you divide it with the number of particles. Then at equilibrium you are told that you are left with what? With 0.4. Now you can find the change, which is going, you can find the number of moles that are at equilibrium by saying 0.5 subtract 0.4, which is going to be 0.1. And because for us to find the number of moles, the change, the one that are produced or that are decomposed at the change, we know that that is where we use what? We use mole ratio. So always the mole ratio will be used at the change. So the equation was 1:2. For every 1 mole of nitrogen tetraoxide, we made 2 moles of nitrogen dioxide. So that is why here, if we get our number of moles of nitrogen tetraoxide as 0.4, we'll use the mole ratio to find the number of moles of what? Of nitrogen dioxide. And remember, this is 0 because at the beginning there was no nitrogen dioxide. So initially it was only nitrogen tetraoxide. Then we are going to find the number of moles at equilibrium, and we are going to divide by our what? By our volume. The volume was provided to us as 4 cubic decimeter. Then we divide by our volume and we find the concentration at equilibrium. After finding the concentration at equilibrium, that's where now you can go to your Kc expression. Remember, your Kc expression will start with the products and the reactants that you are provided on the equation. So you must write the correct Kc expression, because it's 1 mark for the correct Kc expression, not forgetting the exponents, of course. And then these are the values of the concentration at equilibrium, and we find our Kc value as 1,6. And remember, I said we don't include. So it doesn't mean that we mark, remember, normally this is 8 marks. So for the use of mole ratio, you will be awarded a mark. For the subtraction here, you will be awarded a mark. Sometimes for also dividing by the volume, you will be awarded a mark. And also the correct KC expression and the correct substitution until the correct answer. So just know how do you how are you given marks under these KC calculations. In question number 7, that is our acids and bases question with lots of definitions and concepts. But remember that the acids and bases that we are going to deal with, according to the two principles, Arrhenius and Lorentz, because Arrhenius said an acid will do what? Produce an H plus ion. And Lorentz said immediately after producing that hydrogen ion, it will also be able to donate it. So you need to know how does each principle explain an acid and a base, because the examiner will definitely tell you in which way do they want that principle. And then identify acids and bases as strong or weak. Remember, you also need to know the definitions of strong acid, weak acid, concentrated acid, and diluted acid, monoprotic, diprotic, and identify acid conjugate base pairs. These are the few things that I think I just wanted to mention for you to remember as you are going to prepare for your acids and bases. And also here, this is another question where we use our stoichiometric calculations in order to calculate sometimes the concentration, the volume, or the mass, or the number of moles, and the pH, whereby the formula is provided on our data sheet. So it doesn't mean that you need to recall this formula. It is there, it is given to you on the data sheet. And even here, we are not going to give units for the pH. I'm emphasizing here to say copy the correct formula as you are going to do these calculations from the data sheet. Now here is just a recall type of question that says which one of the following is an example of a strong acid. As you know that strong acids are acids that ionize completely, and examples of strong acids were provided to you on the exam guideline. And sometimes if the example was not provided to you, you might be provided a Ka value, which is the equilibrium constant of acid. We are saying if the Ka value is greater than 1, it represents a strong acid. So we know that this is an example of a weak acid. So this is weak. All the carboxylic acids are weak acids. The only strong acid on the given table is our hydrochloric acid. As we are not going to look at all these options, I want us to go straight and look at the long question like this one. Here they say the equation below shows the reaction occurring in hydrochloric acid and ethanoic acid. So we know that this one is a strong acid and ethanoic acid is a weak acid. You are provided with a Ka value, as I said, so that you can determine which acid is strong and which one is weak. So when you look at the first reaction, which is the reaction of hydrochloric acid with water, our Ka value is 1,3 times 10 to a positive 6, but this one is of ethanoic acid is 1,8 times 10 to exponent negative 5. So the Ka value already is telling you that the hydrochloric acid is a strong acid as compared to what? To ethanoic acid. Then define an acid according to Lorentz, which is 2 marks. And then write down 1 conjugate acid base pairs for reaction 1. So this is reaction 1. So you can write any conjugate acid base pair. What is the difference between the acid and its conjugate pair? Is 1 hydrogen. So if you look at HCl and you compare it with Cl minus, what makes them to be different is 1 hydrogen. So this can be the first pair, or you can use water and H3O plus as another pair. Then which solution, 1 or 2, have the lowest pH value, and explain your answer. Now the pH value ranges from 0 to 14, and we know that the pH value of the strong acids is the lowest, followed by the weak acids, and then the neutral substances, the weak bases, and the strong bases. So because we are comparing weak acid and a strong acid, we expect that the pH value of a strong acid must be 1. So it must be the one that is the hydrochloric acid must have the lowest pH. So it means reaction 1 is the one that is having a lowest pH. And the reason sometimes when we explain in chemistry, we just provide the definition to say is because it is a strong acid, it ionizes completely, and also the Ka value is greater than 1 to show that it's a strong acid. So we need to know why are we saying the pH is lower or is higher, and why are we saying a substance is a strong acid or weak acid. This one is just a stoichiometric question that we can be provided for us to calculate. So during the stoichiometric calculations, what I want all of us to know is that all of us, we can get at least the calculation of the number of moles. And somewhere in the question, we must use the mole ratio. And especially when there's acids and bases that are reacting, at the end of the day, they will go into one volume. And normally, we add their volumes. So make sure that at least the number of moles can be calculated is either by using the mass and the molar mass, or also you can also use the formulas that are provided to you on the data sheet to do that. We can just look at number 1. Calculate the number of moles of sodium hydroxide in 10 cubic centimeter of initial solution. So we are provided the concentration of sodium hydroxide, and immediately when you look at our volume is given as cubic centimeters. So we know that we need to convert them into cubic decimeters in order for us to do what? To calculate the number of moles. So we'll definitely calculate the number of moles of sodium hydroxide. And then here we need to calculate the volume. So we know that volume is C is equals to, C is equals to N over V. Because in question 7.2.1, we are going to find the number of moles. We can also try and find the concentration of sodium hydroxide. And because we are given the pH of sodium hydroxide, it means we can use the formula pH is equals to minus log the concentration of H3O plus. And then after doing that, we can also do what? We can also find that POH is equals to concentration of H3O plus this one. So POH is, I normally don't even like this one. You rather use this one to calculate the concentration of what? Of the H plus in this sodium hydroxide, so that you can find the concentration in the volume of this and be able to use it in the formula C is equals to N over V. But definitely you will use this to find the concentration of sodium hydroxide, because you'll be having the pH and you can be able to calculate the concentration of sodium hydroxide. Also here, it is also another stoichiometric question where you are provided one of the standard solution of sodium hydroxide, and you need to use a dilution reaction to do that, which is not what we're going to be able to do. But as I said, we are going to use this to find the concentration of H2O plus, and then use the Kw or POH to find the concentration of OH minus, so that we can find the concentration of sodium hydroxide and use this formula in order for us to find the volume of sodium hydroxide. So such questions, definitely we must expect them, because they are multi-step questions, but all of us, we must get 1 mark for this formula copied correctly, and some of the substitution. And also because we know that we only have the concentration of H3O plus, we can also get another mark when we find the concentration using the constant ionization of water, which is Kw value, which is 1 times 10 to the exponent minus 14. Then the 2 last topics for chemistry is a galvanic cell and an electrolytic cell, which are the topics that we just did recently towards the end of the year. Those are the reactions that look at the redox reactions, the oxidation reduction reactions, and those are the reactions that we know that definitely if we can just thoroughly go through them and study them, we'll definitely get marks. So these are all the factors that are needed in terms of understanding the 2 topics. Energy conversions, they are very important. Know what type of reaction is endothermic and exothermic in terms of being exothermic or endothermic, and in terms of spontaneity, whether it's spontaneous or non-spontaneous. I think this was thoroughly explained to you. And also the use of the reduction potential table, which is very key in order for you to be able to choose the half reactions and also write the correct half reactions, overall reactions, and cell notations for a galvanic cell as we know that in a galvanic cell, that's where we are going to write the cell notation. And also, it will assist you to calculate the EMF of a spontaneous reaction, which we know it falls under our galvanic cell, which is our question number 8. So here, even here, we are saying when you calculate the EMF, make sure that you copy the correct formula from the data sheet. Now, if you can just go to this question, because I just think I need to do this one for a galvanic cell, just to remember what is it that is expected out of us, okay? You know that a galvanic cell, what is it that it will tell you that this is a galvanic cell? When you have 2 electrolytes already, you know that you are having a galvanic cell, especially when it's not a diagram and you cannot identify a salt bridge. You can just check whether there are 2 different electrolytes, because in an electrolytic cell, we have only 1 electrolyte. And then here they say define an oxidation in terms of electron transfer. That are the expectations from the examination. They will tell you whether in terms of electron transfer or in terms of oxidation number. Now, they are saying this cell operates under standard conditions. Remember, what are the standard conditions for a galvanic cell to operate? The concentration of the electrolyte must be 1 mole per decimeter cube. The temperature must be 25 degrees Celsius. And where there is gases, the pressure must be what? And even here, you can see there's a gas, so it means pressure is also affecting half cell B. Now, they say initial concentration of H plus, because it's standard condition. Obviously, the examiner was just saying, what is the concentration of H plus, as you are saying this operates under standard condition. And the name of the metal used for electrolyte B. When you look at electrolyte for half cell B, when you look at half cell B, there is no metal. So where there is no metal, we agreed that we are going to provide platinum as the inert electrode for it to assist in terms of the transfer of electron. So half cell B, because it doesn't have an electrode, we are going to introduce a platinum as an electrode. It might be a cathode or an anode. It depends which type of reaction that half cell B undergo. And then formula of the reducing agent. Now, this is the only time where now you need to go back to the table and say between copper half cell and this oxygen half cell, which one undergo oxidation and which one undergo reduction. And from that, you will see that the one that will undergo oxidation is the one that will give you what? A reducing agent. And in this case, it was going to be our copper. And then the half cell, that is reduction. So as you are going to compare them again using the reduction potential table, you will see which half cell undergo reduction and which one undergo oxidation, and the balance overall reaction where you remove what? The electrons. Then the graph shows the EMF as time progresses. Now we know that when you close the circuit, when the electrons are starting to flow, the EMF of the circuit must decrease. And the reason why the EMF decreases is because of the increase in the product ions and the decrease in the reactant ions. So it means the forward reaction is decreasing. That is why you can see that our EMF starts from a bigger value and decreases up to 0. And where the EMF reaches 0 volts, we know that this is where we mean the cell has reached what? Has reached equilibrium. So it is not that the reaction has stopped, but the cell has reached equilibrium where the EMF is 0. So this is one of the questions that we need to understand and know how can different ways being asked in terms of this galvanic cell. So when they say calculate the value of S, obviously is an initial EMF whereby you use the correct formula that you take from the data sheet to calculate the EMF and calculate the value of X between the copper half cell and that one of what? Of oxygen half cell. Then you get your value of EMF, which was 4 marks. Explain the decrease in the EMF of the cell as the time progresses. I just explained that because of the decrease in the reactant ion and also because of the decrease in the forward reaction. And then what happened to the reaction at T1? At T1, you can see our V cell, our EMF of V cell is 0. And you know that 0 volts means the cell has reached equilibrium. Then the last one is an electrolytic cell, which is our non-spontaneous cell. Our non-spontaneous cell will have different processes, because also here it will be oxidation and reduction occurring, but now the energy for this cell will be provided by a direct current power source. And we know that as we are going to do this energy conversion, they are very close to each other. We need to know which one is different from the other one, and also those parts that will separate or that will distinguish between a galvanic and an electrolytic cell. So what I did here, I just provided the half cells of each and every process. I started with decomposition of copper chloride, and I gave the oxidation and the reduction reaction. So you can even know what are you going to write as oxidation and reduction in each and every process. And also in terms of the refining of copper, copper giving us copper 2 plus, copper 2 plus giving us copper. Know the difference in terms of the change in the concentration of the electrolyte, also the physical changes of the electrode, especially when an electrode is active, whereby the mass decreases and the cathode mass increase when an atom is formed on it. Those are the things that you need to remember, and make sure that as we are asked about the physical properties, we don't talk about the loss and the gain of electrons, because that is what you're not gonna see. And also the electroplating, remember the process of electroplating, whereby we coat one metal by another metal, and you can see everywhere there will always be one electrolyte. And the last one is this one of the electrolysis of concentrated sodium chloride, and this one is having the oxidation and the reduction reaction. So we are going to the examination knowing the oxidation and the reduction reaction of every process. The only thing that you need to remember, how are the processes occurring. Now the last question for the day is going to be this one, okay, just to see what kind of questions can we expect from the examiner. Here you are provided a diagram, and already because there's a battery, you can see that it's an electrolytic cell, and there's aqueous sodium chloride. So from what you know about sodium chloride half cells, you can already know that this question will be based on what? On the electrolysis of sodium chloride, and you will know its oxidation and reduction. Define an electrolytic cell. We can only use energy conversion to do that. And then write down the half cell that occurs at B. Now the B, remember, is your anode. So your anode is long, and your cathode is positive, and your cathode is negative. So we know that at the anode there will be what? Oxidation. So you will write your oxidation half reaction. And already on my previous slide, I gave you the oxidation and the reduction for the electrolysis of sodium chloride. And then the gas bubbles are observed at the cathode. So they're saying there are gas bubbles at the cathode. Now there are only two gases that will be forming in all these processes. It's either it's chlorine gas or hydrogen gas. So what you must know is that always chlorine gas will form at the anode side, and hydrogen gas will form at the cathode side. So if they are saying they are seeing gas at the cathode, you must always expect hydrogen, because our processes are very few, and only hydrogen and chlorine is formed, and chlorine is always formed where? At the anode side, for the decomposition reaction or for the electrolysis process. So just know it's an answer for you to say if there's a gas bubble at the cathode, it must be hydrogen gas only. Write down the name or formula of that gas at the cathode, and then refer to the relative strength of oxidizing agent. Explain why the gas in question is not sodium that is forming. Here is in terms of oxidizing and reducing strength. We know that the two half cells, yes, they will have a sodium ion, and they will also have water. But now, because water is a stronger oxidizing agent than sodium ion, therefore water will be reduced to hydrogen gas instead of sodium ion being reduced to sodium. So that is why sodium, as you're gonna write the two half cells, that is why sodium is not gonna be formed, but what is gonna be formed is what? Is hydrogen gas, because water being a stronger oxidizing agent than what? Than sodium ion. And then normally they also incorporate these stoichiometric questions also here. Don't be scared, just use the same methods as we're using when we're doing KC calculations. when you're also using acids and bases calculation, because here they say an electrolytic cell is using an impure copper electrode consists of 95% of copper and pure copper electrode. Copper 2 chloride is used as our solution, so as the electrolyte. So we are having percentage. So this is just about percentage purity that we did in grade 11. We said percentage purity is equals to, the formula we were given is equals to mass of pure over mass of impure substance multiplied by 100. That is the only thing that you needed to know. And then now, when they say to you, is the pure copper formed at the anode or cathode? Obviously, if you are doing refining, everything that is pure will form at the cathode. So always the pure copper will form at the cathode. In all the reactions that you are going to do, you must know that pure copper will always form at the cathode. When all the copper in the impure copper electrode has been deposited on the electrode, it is found that 6 mole of electrons was transferred. Calculate the initial mass of impure copper. This one is just a pure stoichiometric calculations, where you know that when we are doing this reaction, you said copper undergo oxidation and form copper 2 plus 2 electrons. So you are already told about the moles of electrons, which is 6 moles. So now you must know what are the number of moles of copper that are going to be used to form this number of electrons. And then you are going to use the mole ratio. If this is 2 and then this is X, therefore it means we have 3 moles of copper. Then if we have 3 moles of copper, we can find what? We can find the mass of the pure copper by using the formula, whereby we say 3 is equals to the mass we don't know of the pure copper divided by the molar mass of copper, which is 63.5, and then we are going to get 190.5 and what? Grams. And then we're going to use this formula, whereby you know that this is we're gonna divide by 100, so it's gonna be 95 divided by 100, which is equals to mass of pure copper, which is gonna be 190.5 divided by m, which is gonna be our impure copper, and we find the mass. I think it's gonna be 200.5 something what grams, which is the mass, the initial mass of copper that you got. So go through this and try and see whether you can find this answer. Where you don't understand, go back to your grade 11 work and check your stoichiometry again. Learners, we have just come to the end of our Russian session. I tried by all means to go through all the topics, even though you know that it is going to be very difficult for us to just do all the topics in 1.5 hours. I wish you all the best as you are going to sit for your examination on the 26th of September. From my side, thank you so much for interacting with us, and goodbye.